It is my feeling that in a math tour, especially a math tour for younger kids, it's a great idea if you can have the tour have at least one really big number. Right? There's something sort of exciting about really big numbers. So if we look around the space here, does anybody see a really big number that's sort of crying out? Yeah, I see everybody pointing right down here. I mean, I don't know about you guys, but I look at this like, how many stones did they need to use to make this thing? And it runs to the end of the block. Now, obviously this is a case where we're not going to be able to get the exact number of stones. First off, they had to like take a few out for the trees and so on. But mathematics isn't only about exact answers, it's also about estimating and understanding the world through estimation. So, what are some suggestions for ways that we could estimate the number of square blocks that are used to create this plaza all the way to the end of the block? It's an array, right? It's a rectangular array. So our basic approach is we're going to count across here, and if a couple of you could independently count the length of this row so we can compare answers and hopefully get something that's reasonably accurate. So that's going to work. Now, are we going to count all the little tiny blocks all the way to the end of the, no. So I hope a couple of you are doing this count. No, we're not going to count all the blocks all the way to the end of the block here. So again, how can we estimate that number? Yeah, we're going to multiply again. This shows how powerful multiplication is. So I need somebody to take one full big square and count how many of these little squares make up one full big square. So if a couple of you could do that. And then I need some more of you to start going down the block and count how many of these big squares you pass. And I'm going to rely on you all to keep those numbers. Don't try to keep two of them. If you did this, don't do the others. If you're doing this count here, don't do the others. If you're doing this count along here, don't do the others. At the end of the block, we'll do our calculation. So it's a big, long rectangle. And we're going to first try to get an estimate of the number of stones long this whole thing is. So who counted the number of stones per big sidewalk block? Okay, 26. I'm hearing lots of 26s. Okay, so we have 26 little stones per big block. All right, 26 of those times how many of the big blocks were there? 18. I heard 18. 14 and a half. Did we get any other numbers? Okay, well, let's say 16. That's in between the different, we have two different data points, so we'll take right in the middle. So 26 times 16 is 416 blocks long. And now what counts do we get for the number of blocks along the short side here? 45. 45. I'm hearing consensus on 45, so I'm going to multiply that by 45. And I get 18,720 as our estimate for the number of little blocks here. That is a bona fide, really big number, and it's just amazing to think about the stack of 18,000 blocks high. If each one of these blocks is only 2 inches tall, let's say, I don't know how, I didn't dig one up, so I don't know. Let's imagine it's only 2 inches tall, so times 2, that's 37,440 inches. I'm going to divide that by 12. That's 3,120 feet. That's more than half a mile into the sky that these blocks would go if you stacked them all up like a tower of blocks. I think that's pretty exciting for kids.